Hello, everyone. Welcome back to this online class. Today, we are going to look at the bivariate Lagrange interpolation technique. Now we have this question. We are asked to discuss the bivariate Lagrange interpolation technique and hence work out the following question. We are told the following data represents a function f of xy. So we have that table of x values versus y values and also f of xy values. The values in black are the f of xy values because the row values 0, 1, 4, those are x values, and then 0, 1, 3, those are the y values. Now, obtain a bivariate Lagrange interpolating polynomial that fits the data. Hence, use the polynomial to estimate the value of f of 2, 2. So first of all, let's talk about the bivariate Lagrange interpolation. So I want us to take note that the word bivariate or the term bivariate simply means bivariate means a function of two independent variables, two independent variables. So you can now say, e.g., f is a function of x and y. So x and y are the independent variables. Now, how do we interpolate such kind of a function? So usually this is the formula that you always use, that the bivariate Lagrange interpolating polynomial takes the general form. So general form of the bivariate Lagrange interpolating polynomial is given by, let me write it here, that is f of x, y, f of x, y is approximately equal to the sum from I is equals to 0 to m, another sum from j is equals to 0 to n, Li of x, Lj of y times f of xi, comma, there should be a comma, xi, comma, yj. So it's a double sum to mean bivariate. Now, the I ranges from 0 all the way up to m, j ranges from 0 all the way up to n. So you can say where, let me write here, where I ranges from 0, 1, 2, all the way up to m, and j ranges from 0, 1, 2, all the way up to n. So this is the Lagrange, the bivariate Lagrange interpolating polynomial. So what is this Li of x and Lj of x? Those are called the Lagrange coefficients. So you can write this, that the Lagrange coefficients, Lagrange coefficients, that is Lix and Ljy, are given by So let me tell you how we define those coefficients. We start with the Li of x. So Li of x is simply equal to the product. The product from P is equals to 0 to M, P not equal to I, P not equal to I, of x minus xp over xi minus xp. That's how we define that coefficient, Li of x. Now let me expand it so that you see how it's written, because there's a product. So this can be written as x minus x naught, x minus x1, x minus x2. There are so many other factors in between. Then there is x minus x I minus 1, x minus x I plus 1. So many other factors up to the last one, x minus xm. Denominator is now, where there is x in the numerator, you replace that by xi. So we'll have xi minus x naught, xi minus x1, xi minus x2, so many other factors, xi minus xi minus 1, xi minus xi plus 1, so many other factors, to the last one, xi minus xm. This is the first one. The other one is Li of y. That's now a function of y. So write similarly, no, that's Lj, not I. That should be Lj of y is equals to the product from q is equals to 0 to n, q not equal to j, q not equal to j, of y minus yq over yj minus yq. And so when you expand again this one, you're going to get this kind of a product, that y minus y naught, y minus y1, y minus y2, times so many other factors, y minus yj minus 1, y minus yj plus 1, times so many other factors up to the last one, y minus yn. To get the denominator, where there is y in the numerator, you replace that by y subscript j. So that we'll have yj minus y naught, yj minus y1, yj minus y2, times so many other factors, then times yj minus yj minus 1, yj minus yj plus 1, times yj minus yn. Those are the Lagrange coefficients. So now, having discussed the formula for the used in bivariate interpolation, let's now answer the question. This is the table. We are going to come up with the coefficients based on the data you have been given, and then come up with the interpolating polynomial. So of course, as usual, from your table, let me use another color so I can pick green. This is our x naught. This is x1. This is x2. Similarly, this is y naught, y1, y2. So the value one here is f of x naught, y naught. This is f of x naught, y1. This is f of x naught, y2. In that order, this one is f of x naught. No, this is now x1, y naught, f of x1, y1, and this is f of x1, y2. And the other one is 49 is f of x2, y naught. Here it is f of x2, y1, and this is f of x2, y2. So we know the values now. Let's go back. Now look at, we have x naught, x1, x2, y naught, y1, y2. It means our m is 2 because I ranges from 0 to m and j ranges from 0 to n. So m is 2 and also n is 2. So our polynomial, the interpolating polynomial should now be of this form. So now we are answering the question. I'll work out the question. The question. Remember, we have said that m is 2 and also n is 2 because we are going all the way up to x2 and y2. So that our polynomial takes this form. We now talk of f of xy is approximately equal to the sum from I is 0 to 2. Again, another sum from j is 0 to 2. Li of x, Lj of x, and that should be Lj of y, Lj of y times f of xi, comma yj. Just the same polynomial that I gave you with m and n, but now in this case, we know the values of m and n, 2 in each case. Let's open up this summation. This is the same as writing. Now, it is the same as the sum from I is equals to 0. You start by opening the inner summation to 2 of Li of x. Then the inner summation will now give us, when j is 0, you get L naught of y, f of xi, y naught. Remember, j is 0. Now when j is 1, it is L1 of y, f of xi, y1, plus when j is 2 is now L2 of y, f of xi, y2. That's the inner summation. Now let's open the outer summation now, so that this will now give you, when I is 0, you get L0 or L naught of x times the entire bracket L naught of y, f of x naught, y naught, plus L1 of y, f of, remember I is 0, x naught, y1, plus L2 of y times f of x naught, y2. That's when I is 0. Then plus when I is 1, you'll get L1 of x times again the entire bracket, that is L naught of y, f of x1, y naught, plus L1 of y, f of x1, y1, plus L2 of y, f of x1, y2. And lastly, when I is 2, we are going to get this. So when I is 2, we get L2 of x times the entire bracket, that is L0 of y, f of x2, y0, plus L1 of y, f of x2, y1, x2, y1, plus L2 of y, f of x2, y2. So that's the form of our polynomial when we open up the summation. Now, let's see how to find those coefficients. We're going to start with the L as a function of x, and then the L as a function of y. So now, we can just write now our coefficients. Let's start with L0 of x. How is it defined? It is x minus x1, x minus x2. Everything over x0 minus x1, x0 minus x2. So let's substitute. I don't know x, but do we know x1? That was 1. Do we know x2? That is 4. x0 is 0, so 0 minus 1 and 0 minus 4. When you press this in your calculator, you need to get 1 over 4. 1 over 4 times x squared minus 5x plus 4. That is L0. Do the same to get L1. L1 of x. It is equals to x minus x0, x minus x2 over x1 minus x0, x1 minus x2. So what will this be equal to? X minus 0, because our x0 is 0, x minus 4 plus x2. Our x1 is 1, so 1 minus 0 times 1 minus 4. That should give you negative 1 over 3 times x squared minus 4x. That's what we get. And the other one is L2 of x. So take this up. We still have L2 of x. That's the same as x minus x0 times x minus x1 over x2 minus x0, x2 minus x1. When you work it out, you're going to get x minus 0, x minus 1 over 4 minus 0, 4 minus 1. And so that is 1 over 12 times x squared minus x. Similarly, those for y, let me use another color. L0 of y is the same as y minus y1 times y minus y2. Everything over y0 minus y1, that should be y1, minus y1, y0 minus y2. So what will this give us? It is the same as y minus y1 was 1 and y2 is 3 over y0 is 0 minus 1, another 0 minus 3. That should give us was 1 over 3 times y squared minus 4y plus 3. Similarly, L1 of y is equals to y minus y0, y minus y2 over y1 minus y0, y1 minus y2. So this is the same as writing, if I'm substituting y0 and y2 and even y1. So we'll have y minus 0 times y minus 3 over 1 minus 0 times 1 minus 3. And so when you work it out, you're going to get negative 1 over 2 times y squared minus 3y. And finally, L2 of y is equals to y minus y0 times y minus y1 over y2 minus y0 times y2 minus y1. And so again, when you substitute those constants, you need to get y minus 0 times y minus 1 over 3 minus 0 times 3 minus 1. So again, that should be able to give you 1 over 6 times, so that's 1 over 6 times y squared minus y. Now we have the coefficient. So let's substitute them back into our interpolating polynomial. That is f of xy approximately equal to this one. We are going to replace all these coefficients here. Let's see what we are going to get. So you can say therefore, hence, our f of xy is approximately equal to, we start with L naught of x, that was 1 over 4 x squared minus 5x plus 4. That's L naught times that, the whole of that bracket, L naught of y is 1 over 3 times y squared minus 4y plus 3. Then this should multiply. Let me take you back. I'm replacing here. I've started with this. I've written this. I've also written this. Now I need f of x naught y naught. We have it from the table. We check those values from the table here. Already we had specified the values. F of x naught y naught, that should be 1. It is this one. So I pick that. So I'm going to replace that value by 1. Let me take you down. So this one is times 1. Then followed by y1 of y, which again we have as negative 1 over 2. So instead of a minus, a plus, I'll write a minus 1 over 2 y squared minus 3y. This should multiply f naught, f of x naught times y1, which again is 1 from the table. Then lastly plus L2 of y, which is 1 over 6, y squared minus y times f of x naught y2. That again was 1. So that's the first, simply the first line in this equation. See, we have replaced everything here. I've replaced this, also this. Now let's go to this other one, L1 of x. Do the same until you replace all of them. So you replace L1 of x and the entire bracket, read the f of x, y values from the table. Do the same to L2 of x and also the entire bracket and read the f of x2, y naught, etc. from the table. So let me take you down. After replacing, this is what you need to get. So we need to simplify this one so that we get our polynomial in its simplest form. So this can as well be written as, when you simplify, we are going to get 1 over 4 x squared minus 5x plus 4. The whole of this bracket should give you 1. If you work it out, you will get 1. So that should be 1. Go to the other, of course, I've written this, then times 1, which I don't need to write 1. Then now this one, negative 1 over 3 times x squared minus 4x. Let's work out this other bracket. What do you need to get? If you work it out, because I know you can do it, you are going to get y squared plus 4. So I'm going to write here times y squared plus 4. Then now here is 1 over 12. 1 over 12 times x squared minus x. When you work out this other bracket, the whole of this, you need to get 4y squared plus 49. 4y squared plus 49. So you can just say, or f of xy. Of course, this should be approximately equal to, because it is an interpolating polynomial, so it can't be exact. So it's approximately equal to that. So this is our polynomial, the interpolating polynomial for the given data. So let me bracket it. Now I want us to use this polynomial to be able to obtain f of 2, 2. That is the value of f when x is 2 and when y is also 2. So you can write put x is equals to 2 and y is equals to 2 to get, that will now give us f of 2, 2, f of 2, 2, which will be approximately equal to, when you substitute 2 and 2 and you place in your calculator, you need to get the value of f of 2, 2 to be 21. So that's how to use bivariate Lagrange interpolating polynomial. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When you meet next time, we look at more problems involving bivariate Lagrange interpolation technique. Bye-bye.